f of x is equal to 4 cosec x minus 4x plus 1, where x is in radians. Part A, show that there is a root of alpha of f of x equal to 0 in the interval between 1.2 and 1.3. So first let's substitute 1.2 into the function. Obviously I can't really substitute it into cosec, but I can write 4 cosec as being 4 over sine. So this is the same as me doing 4 cosec 1.2 minus 4 lots of the 1.2 plus 1, which gives 0.491, so positive. If I do the same thing with 1.3, so 4 over sine 1.3 minus 4 lots of 1.3 plus 1, and that gives minus 0.048, blah, blah, blah. So negative. So we can now write the usual sentence, sign change in the continuous function sign change in a continuous function, so there must be a root in the interval 1.2 to 1.3. Part B, show that the equation f of x can be written in that. F of x equals 0 can be written in that form. So let me take the f of x function, so the 4 cosec x minus 4x plus 1 equals 0, and I'm going to add 4x to both sides. So 4 cosec x plus 1 equals 4x. I'm then going to divide both sides by 4. So cosec x plus 1/4 equals x. And then let's just remember that cosec is actually just 1 over sine. So 1 over sine x plus 1/4 is equal to x, which is what I needed to show. Part C. Use the iterative formula, xn plus 1 equals 1 over x sine xn plus 1/4 with x0 equals to 1.25 to calculate the values of x1, x2 and x3, giving your answers to 4 decimal places. So to get x1, I'm going to do 1 over sine 1.25 plus 1/4, which gives 1.3038 to 4 decimal places. To get x2, I'm going to take that answer, the x1 answer, and substitute that into my formula. So I'm doing 1 over sine answer plus 1/4, which gives 1.2867 to 4 decimal places. And then I'll do this one more time for x3. So just pressing equals, so 1 over sine answer plus 1/4, and I get 1.2917 to 4 decimal places. Part D. By considering the change of sign of f of x in a suitable interval, verify that alpha equals 1.291 correct to 3 decimal places. My suitable interval will be the upper bound and the lower bound of alpha. So the lower bound is 1.2905, the upper bound is 1.2915. Let's substitute those into the function. So f of 1.2905. So substituting that into my original function, I get 0.0004. So a positive. Now doing the same with the upper bound, I get minus 0.0047. So a negative. So sign change in the continuous function So there must be a root in this interval where all numbers round to 1.29123 decimal places.